Hey Fast Track, in this video I'm going to show you how to graph radians on the coordinate plane and also find coterminal angles. So to start, let's learn how to graph radians on the coordinate plane, but let's review real quick. Let's start with degrees. This right here is 0 degrees. 1 full revolution is 360 degrees. That makes this 180. This is 90, so this right here is 270. Now remember, radians are just another way of measuring an angle. So this right here is 0 radian. 1 full revolution in radians is 2 pi. So 2 pi is equivalent to 360 degrees. I forgot to mention that. Make sure you watch the video on the unit circle first and then watch this one. Now half a revolution, or in other words a semicircle, is half of 2 pi, which is 1 pi. And half of pi is pi over 2. In other words, each quadrant is pi over 2. So from here to here is 1 pi over 2. So from here to here will be 2 pi over 2. Of course, reduces to pi. 90 more degrees, you're at 3 pi over 2. And 1 quadrant more leaves you at 4 pi over 2, which reduces to 2 pi. So the important part that you guys have to know is the following. The part that I left on the coordinate plane. Now let's go ahead and graph 7 pi over 6 on the coordinate plane. So if you remember from the unit circle, the only radians you've seen were with denominators of 2, 3, 4, and 6. So for example, pi over 2, pi over 3, pi over 4, and pi over 6. So let's graph the following on the coordinate plane. So notice that the denominator is 6. So we're going to relate this coordinate plane with pi over 6. So here's how you do it. So from our previous slide, you know that this right here is pi, and 1 full revolution is 2 pi. But we're going to relate our coordinate plane to pi over 6. So from here to here, you're going to have 6 pi over 6. And you should know that that right there is correct because 6 pi over 6 reduces to 1 pi. So if half a revolution is 6 pi over 6, 1 full revolution will be 12 pi over 6. And you know that's correct because 12 pi over 6 reduces to 2 pi. So we'll go ahead and erase the following. Now, keep in mind that we're trying to graph 7 pi over 6. But here, let's label our 90 degrees and our 270 degrees. So if from here to here we have 6 pi over 6, halfway we have 3 pi over 6. It does reduce, but let's not reduce it. So in other words, each quadrant is 3 pi over 6. So down here we're going to have 9 pi over 6. And again, because each quadrant will be 3 pi over 6. So we're trying to graph 7 pi over 6. So remember, to graph an angle, you start from the positive x-axis. And since our radian is positive, we're going to go counterclockwise. So from here to here, you have 6 pi over 6. So you need 1 more pi over 6. So that leads you right here. So that right there is 7 pi over 6. Now for example 2. Look at the denominator. The denominator is 4. So we're going to relate our coordinate plane to pi over 4. So from here to here, you should already know that that right there is pi. 1 full revolution, you should know that that right there is 2 pi. Now, we're going to relate our circle to pi over 4s. So this right here will be 4 pi over 4, and you know that's correct because 4 pi over 4 reduces to pi. If a half a circle is 4 pi over 4, 1 full revolution will be 8 pi over 4. Now let's just fill in the remaining degrees, the 90 and the 270. So from our previous steps, from here to here will be 4 pi over 4, so half of that will be 2 pi over 4. In other words, each quadrant is 2 pi over 4. So 2 pi over 4, 4 pi over 4, So this right here will be 6 pi over 4. And of course, 6 pi over 4 plus 2 pi over 4 will be 8 pi over 4. Now you start at the positive x-axis and you're going counterclockwise. So from here to here, you have 8 pi over 4. You need one more pi over 4. So that leads you right here in the first quadrant. So that's your angle for 9 pi over 4. So notice that if you go too far, you're going to be too big. So for example, if I start here and do 8 pi over 4. So notice again that one revolution is 8 pi over 4. If I keep going all the way here, I'm already at 10 pi over 4. That's why we stop right here in the middle and call this 9 pi over 4. For example 3, we're going to relate our unit circle. For example 3, we're going to graph 13 pi over 3. So we're going to relate our coordinate planes to pi over 3. So this right here will be 3 pi over 3. One full revolution will be 6 pi over 3. So let's label our 90 and 270 degrees. So from here to here, you have 3 pi over 3. Half of that will be 1.5 pi over 3. So each quadrant is 1.5 pi over 3. So from here to here, you have 3 pi over 3. And if you add 1.5, you get 4.5. And if you add 4.5 plus 1.5, you get 6 pi over 3. So let's graph 13 pi over 3. Let's start at our positive x-axis and go counterclockwise. So one full revolution, we're at 6 pi over 3. Notice that we're trying to get to 13 pi over 3. So that's 2 full revolutions, which land us at 12 pi over 3. We're trying to get to 13. So you have to go one more pi over 3. So that right there is the graph for 13 pi over 3. Go ahead and try graphing the following radian. Pause the video and come back. Very first step, go ahead and label your coordinate plane with pi over 5. This right here is 5 pi over 5. One full revolution will be 10 pi over 5. So notice that you are trying to graph 24 pi over 5. So far one full revolution is 20 pi over 5. So notice that those are too small, but let's go ahead and start. Start at the positive x-axis. Again, one full revolution is 10 pi over 5. 2 full revolutions will be 20 pi over 5. So right now we are at 20 pi over 5. So notice that we need 4 more. So we need 4 pi over 4. If we go all the way here, that is 25 pi over 4. So therefore you have to stop right before you get to 25 pi over 4. And here is your theta, 24 pi over 5. So let's graph the following theta. In this problem, theta is equal to negative 13 pi over 4. So let's go ahead and graph it. Here's our coordinate plane. Notice that this time our radian is negative. If you remember from graphing angles in degrees, you know that we're going to go clockwise this time. So again, let's first, let me start here. We're going to start at the same spot, the positive x-axis, and we are going to go clockwise this time. So we relate our angle to pi over 4. From here to here, we're going to have negative 4 pi over 4. One full revolution will be negative 8 pi over 4. So let's see where we're at. Each quadrant will be 2 because from here to here is 4. So half of that will be 2. So negative 2 pi over 4, making this negative 6 pi over 4. So if I start at the positive x-axis. If I go one full revolution clockwise, I'm at negative 8 pi over 4. If I have 4 more, I'm at negative 12 pi over 4. to get to 13, I need one more, so go this way. So here is the angle for negative 13 pi over 4. It lands in the second quadrant. Now that you know how to graph radians on the coordinate plane, let's move on and find coterminal angles. So coterminal angles are angles with the same initial and the same terminal side. In other words, angles that start and end with the same side. So to make this easier, let's start with degrees. Okay, for example 5, we're going to find the coterminal angle for 50 degrees. Very first step is to graph it. 50 degrees is in the first quadrant. So remember, by definition, the coterminal angle is an angle that has the same initial and same terminal sides. In other words, an angle that starts and ends in the same location as the 50 degree. So the very first thing you can do to find another angle that's coterminal the easiest is basically add another revolution. For example, from here to here you have 360, and if you add 50 more, you get 410. So theta equals 410 is a coterminal angle to 50 because they start and end on the same side. And let me graph them on separate coordinate planes so you can see it. And then 410 was one full revolution plus 50 more. So notice that they have the same initial and the same terminal side. So if you want one more, you can basically add one more revolution. So from here to here, 360, 720, add 50 more, you get 770. In other words, just keep adding revolutions to get another coterminal angle. But those are the positive coterminal angles. You can also find negative coterminal angles. So let me show you how to get those. So again, the theta that we're dealing with is 50 degrees. Here is the initial side, here is the terminal side. So from here to here, you have 50 degrees. Now, let's say I asked you for a negative coterminal angle to 50 degrees. So you would just go clockwise. So this will be our initial side. And if I go this way clockwise, here's our terminal side. So those two will be coterminal. So to find that degree right there, that theta, or in other words, the radian, you would do 306. Well, we are doing degrees, so let's call it degrees. So to get that degree, you will do 360 minus 50. And of course, you get 310 degrees. And of course, that'll be negative. If you add another negative, if you want another negative coterminal angles, all you have to do is add another negative revolution. So add negative 360 degrees. That will leave you at negative 670 degrees. Because if you graph it, here is the initial, one full revolution, and if you go 310 degrees more, it lands you as the exact same spot as theta equals 50 degrees. So remember, a coterminal angle is the angle that starts and ends on the same side. Now, example 6, find the coterminal angle for 100 degrees. So let's find two positive. No, let's just find one positive and two negatives. Very first step is to graph 100 degrees. So here is the initial side. That's 90, so 100 degrees is right there. And here is the terminal side. So all of our angles should start here and end right here. So let's find a positive coterminal angle first. So remember, all you have to do is add a full revolution. So from here to here is 360, add 100 more, you have the same initial and terminal side, making a coterminal angle to 100 to be 460 degrees. And again, I got that by doing 360 plus 100. Now let's say you want a negative coterminal angle. So you start by graphing 100 degrees. So it's from here, here's your initial side. Let me do that in yellow. Initial side, terminal side, theta equals 100 degrees. If you want a negative coterminal angle, you're gonna go clockwise. So here's our initial side. It'll be from here to the terminal side. So to get the angle, you just subtract 100 from 360 and you get negative 260. If you want another negative coterminal angle, just add another revolution. So for example, it'll be from here. So negative 360 plus negative 260. That'll be negative 620 degrees. So remember, all I have to do is keep adding revolutions. So go ahead and try to find the coterminal angles for theta equals 405 degrees. Go ahead and find 2 positive and 2 negative. Pause the video and come back. So first, let's start by graphing our 405 degrees. So from our positive x-axis, we're going to go 1 full revolution. That's 360 degrees. So notice that if you do 405 minus 360, you get 45 degrees. So we need 45 degrees more. So that right there is 405 degrees. So let's find a positive. Let's find 2 positive coterminal angles first. So remember, it has to start here on the same initial side and end here on the terminal side. So the easiest one is the angle from here to here. And technically, we already found it. That angle there is 45 degrees. And those two are coterminal because they start and end on the same side. So our first angle there that is coterminal to 405 is 45 degrees. If you want another positive coterminal angle, all you have to do is add a revolution. So let me redraw it. From here to here, you have 360 degrees. Now, if you do 360 plus 45, that just lands you back at 405. So add a full revolution. So 2 full revolutions will leave me at 720. 720 plus 45 will be 765. And again, if you want another positive, just keep adding full revolutions. Now let's look for 2 negative coterminal angles. I'm going to start again by drawing my angle. Here's our initial side. From here to here is 360. I needed 45 more. That lands me at 405, and we're going to keep this 45 degrees in mind. Now, to find a negative coterminal angle, we're going to start at the positive x-axis and move clockwise. So the first one that I could see is from here all the way to here. In other words, 360 minus 45, which will be negative, well, it'll be 315. And since you went clockwise, you know that the first negative coterminal angle is negative 315 degrees. If you want another negative, add a revolution, you get negative 675 degrees. If you don't believe me, graph it. You'll see that it's going to start and end on the exact same spot as 405 degrees. So for example 7, let's find coterminal angles for 5 pi over 6. The very first thing is to graph it. Since our denominator is 6, we're going to relate our coordinate plane to pi over 6. So this right here will be 6 pi over 6. 1 full revolution will be 12 pi over 6. If you want to label our 90 and 270 degrees, this will be 3 pi over 6. This will be 9 pi over 6. So let's graph 5 pi over 6 first. So let's start at our positive x-axis. Here's our initial side. Your terminal side will be in the second quadrant. So theta equals 5 pi over 6. So remember, if you want to find a positive coterminal angle, go ahead and add a full revolution. As is, we're doing radians now, 1 full revolution is 12 pi over 6. So 5 pi over 6 plus 12 pi over 6 gives you 17 pi over 6. So theta equals 17 pi over 6 will be your first coterminal angle to 5 pi over 6. Now, if you want another positive coterminal angle, just add another full revolution and you keep on going. But I'm more interested in finding the negative coterminal angles. So let me do that in white. So it'll be the angle from here to here. So we're going clockwise this time. Keep in mind that 1 full revolution is 12 pi over 6. If you know that this right here is 5 pi over 6, you just subtract those and you get negative 7 pi over 6. Now that you have that, you have a negative 7 pi over 6 as a coterminal angle. If you want another one, just add a full revolution and you get, and again, a full revolution is negative 12 pi over 6. And if you add those, you get negative 17 pi over 6. That's not right. That'll be negative 19 pi over 6. So here's example 8. Let's find 3 coterminal angles to 7 pi over 4. The very first thing, you graph it. Our denominator is 4, so let's relate our coordinate plane to pi over 4s. 4 pi over 4. That means halfway is 2 pi over 4. This is 6 pi over 4. 1 full revolution will be 8 pi over 4. Now 7 pi over 4. The angle starts right here. 1 full revolution is 8 pi over 4. We want 7, so we want 1 less. Now, if you want a positive coterminal angle, just add a full revolution. 1 full revolution is 8 pi over 4. That leaves you with 15 pi over 4. So that's the first coterminal angle. Now let's find the negative coterminal angle, which is the angle that starts at the positive x-axis and goes clockwise. Keep in mind that 1 full revolution was 7 pi over 4. We stopped at 7 pi over 4, making this angle right here negative 1 pi over 4. So that's our first coterminal angle, negative pi over 4. If you want another negative, just add another revolution and add one more. That will land you at 1 full revolution was negative 8 pi over 4. And if you add negative 1 pi over 4, that leaves you at negative 9 pi over 4. So here is example 9. Let's find coterminal angles to 11 pi over 3. Very first step is to graph it. Our denominator is 3, so this will be 3 pi over 3. 1 full revolution will be 6 pi over 3. So let's start. This right here is the beginning. If you do 1 full revolution, you're at 6 pi over 3. We're trying to get to 11. So if you do 2 full revolutions, you are at 12 pi over 3. You're trying to get to 11. So you're going to stop right here, right before you reach 12. Now, the very first coterminal angle you can find is the positive one. And you get that by adding a revolution. So 11 pi over 3 plus 6 pi over 3 gives you 17 pi over 3. So that is your first positive coterminal angle. Now there's one more we could have found that's also positive but smaller than that. So notice that it is the angle that goes from here, goes this way and stops right here. So if you remember when we started graphing, this right here is 1 pi over 3. If 1 full revolution is 6 pi over 3, and if you take away 1, that leaves you with 5 pi over 3. So both of those are coterminal to 11 pi over 3. Now let's find a negative coterminal angle. So this right here was 3 pi over 3. This was 6 pi over 3. 2 revolutions was 12 pi over 3. Here's our initial side. 1 revolution is 6. We have to stop right before we hit 2 revolutions. So that is 11 pi pi over 3. So to find a negative coterminal angle, we wanted to start here and end here. The very first one is this one here. Again, 2 full revolutions was 12 pi over 3, but we stopped at 11, making this right here negative pi over 3. If you want another one, just add a full revolution, which is 6 pi over 3. That will land you at negative 7 pi over 3. So this is the final problem. Go ahead and try to find 2 positive. Just go ahead and find, 2 positive and 1 negative coterminal angle to this. Let's start by graphing it. Our denominator is pi over 4, so this right here is 4 pi over 4. 1 full revolution will be 8 pi over 4. And know that each quadrant will go by 2. Now we are at 25 pi over 4. Start here at the positive x-axis. 1 full revolution is 8 pi over 4. 2 full revolutions is 16 pi over 4. If we do 3 full revolutions, we are at 24 pi over 4. So notice that we need 1 more to get to here. So pi over 4 is right here. So here is our theta, 25 pi over 4. So the very first coterminal angle that I see that's positive is the angle from here to here. So keep in mind that 3 full revolutions was 24 pi over 4. To get to 25, we moved up 1 pi over 4. So the very first coterminal angle is pi over 4. If you want another positive one, just add another revolution. That will give you 9 pi over 4, and so on. So there's infinitely amount of coterminal angles, by the way. I forgot to mention that you can keep on going and going and going. So now that we know that this is pi over 4, let's go ahead and find a negative coterminal angle. Keep in mind that 1 full revolution will be negative 8 pi over 4. So the very first negative coterminal angle will be from here. Let me redraw it. So our 25 pi over 4 started here and ended here. So the first negative coterminal angle is the angle from here to here. And earlier we found out that this is pi over 4. And we know that 1 full revolution is 8 pi over 4. So this right here will be negative 7 pi over 4. And just keep adding revolutions. That will land you at negative 15 pi over 4.